I just want you to know, typically for three-dimensional problem, you should be able to have 6 equations, but I'm not going to ask you to solve any specific questions in the final test. Okay, so then next one is chapter 5. Here, right? So chapter 5 talk about basically 2 concepts, but you can combine those 2 together because the centroid of an area is always equivalent to the center of gravity. Our goal in this chapter is to calculate the center of gravity, but we just need to identify the centroid of that area because that's the same point with the center of gravity. And the centroid calculation is what we call x bar, y bar. Okay, following the final equation having x bar equal to this one divided by a, y bar equal to this one divided by a. But in general, we're not going to ask you to do integration by yourself. So what we're asking you is basically using the composite rule to, where's composite rule? To calculate the centroid x bar, y bar in capital by splitting a little bit more complex area into a few simple areas. And that procedure is called superposition. So that's why whenever we ask you such question, I really suggest you to split this a little bit more complex area into a few by plotting like this way. And also you need to make sure every part should follow the same coordinate system. That's what I call the common language, so that each case can talk to each other. Okay? Now, another thing I want to point out, this one. You need to memorize those 3 cases. As I told you before, I just want to reiterate. These 3 cases may be used to calculate the centroid. So that's why you do need to memorize those 3. For others, you don't have to. Just in case I gave you, I will tell you those results. Okay? But I really want you to memorize those 3 cases. Triangular, a quarter circle, and a semicircle case. Okay, so these are the 3 cases I want you to memorize. Okay? And that is the first part of chapter 5. But there's another part, second part of chapter 5, which is to apply such centroid concept to solve some beam problems. So if we have a distributed load like this, then if I'm asking you to calculate reactions, of course the first step you need to plot the free body diagram, but then you still need to make the equivalence from a distributed load to a concentrated load. And that is basically finally to have this distributed load equivalent to a concentrated load and somewhere. The magnitude of the concentrated load is the area of this one, and the location, x bar, is the centroid. So that's why I call the application of centroid concept for solving beam problem in terms of reactions. So this is chapter 5. Now we are moving to chapter 6. Chapter 6 talk about applications, right? From chapter 4, basically we talk about a specific special structure that's called truss. In order to solve internal forces with a given truss, you have 2 methods. One is called the method of joints, allowing us to calculate all the internal forces. If you were given a problem asking you to calculate all the internal forces, you have no options. You just have to use the method of joints to calculate all member forces. You don't need to think about it. As long as you identify this is a truss structure, then you just use the method of joint. But many times we may say, okay, you only need to calculate a few member forces. A few means 1, 2, 3, most likely, right? If that's the case, you need to think about the second method first, which is called the method of sections. The method of sections is to make a simple cut, going through those internal the members. You want to calculate the internal forces. For example, if we are asking you to calculate the internal forces for members FH, GH, and GI, So then you need to make a cut. But before you make the cut, you are supposed to calculate those reactions. That's always the first step. So then you make the complete cut. Okay, complete cut means you need to split the structure into two parts. And then you just use the equilibrium concept to see whether you have 3 unknowns and you have 3 equations or not, right? So this is the typical way you can solve the problem using method of joints. Of course, I talk about some rare cases like this, but I'm not going to let you cut something like this because even myself may have a hard time to figure out how to make this very smart cut. I even do not know. But just in case, if I do give you this case, I'm going to tell you how to cut. But typically, I'm not asking you to solve this kind of problem. You need to have some kind of simple cut in order to solve a few internal forces. Okay, so that's called the method of sections. So now I'm coming back to talk about the first method. Part of the first method is to identify the zero forces. So that's the one I'm gonna emphasize again. So basically, we're talking about 2 cases. Either when you have a joint with only 2 members involved, and there's no forces acting on this joint either, right? So you only have 2 forces. You only have two members, and this angle can be anything except 180 degrees, which means it can be anything except this case. So this is not this case. If this is the case, then immediately you can say the internal force of AD and internal force of AB are both 0. That's called the zero force members. Okay, if you encounter this case. The other case, which I want you to understand, is having 3 members connected with the joint, and there's no forces. And among these 3 members, 2 of them are in one direction, in 180 degrees. Then the third member should have 0 force. So that means you don't have to cut. You can conclude the internal force of AC is equal to 0. And that's why I gave you quite a few questions, right? So most likely in the final test, the first kind of question, I'm going to just give you some kind of a truss structure and let you identify what we call the zero force members. So if that's the case, again, you really do not need to do that calculation. You're supposed to find those zero member forces in just a few minutes. So those are the questions I don't count typically as one of the major questions, because I really want you to get it down just in a few minutes. Okay? So that's what I call the zero force members, and these are the 2 cases you really have to understand. Yes?
So just want to make sure, in the final test we have a zero force member question, we just need to write down all the zero force members.
Right.
That's right.
So for example, if I gave a certain structure like this, for example, right? I already talked about this. Suppose you have 3 zero force member, right? If you write 2, if you only identify 2, you won't get a full credit. Most likely get 2/3, right? And if you get only 1, then of course you're going to get half credit at least. At most, okay? But on the other hand, you say, okay, I'm going to write this. In addition, I'm going to write something else. Then it's not correct either. Okay? So the correct answer is 3 members. But if you identify 6 or 4 or 5, we have to decide what kind of accuracy you can get. But most likely, you won't get full credit if you write more members. Okay? Any other questions? And this is important, right? So again, I really want you to understand those 2, okay, without using calculations. Of course, use calculation, you finally get it, but it takes an hour. So that's why I want you to spend just a few minutes to identify certain zero force members. And you really need to go back to look at those kind of homework questions I gave you, right? Just in case you, for whatever reason, you cannot remember now. So these are the principles you really have to know. Okay, so this is chapter 6, and then we have chapter 7. That's, I believe, the most important part is to plot the shear and moment diagram. So I guarantee you're going to have 1 complete question asking you to plot shear and the moment diagram in the final exam. It's going to be a complete question. Okay, I give you 2 pages basically, right? Okay, to solve such problem. So that's why you should not only plot. You should give me the procedures. Okay, step 1, to calculate the reactions, most likely, right? And then you're going to decide how many segments you need to cut. Okay, each segment, write down those equations. Okay, if you do not write those equations, for whatever reason, you just plot directly, and many times those are not straightforward. How I'm going to assume you know how this you calculate it, right?